Water from the well and good morning students. We will continue again with unit number 3, topic number 5. Good morning students. We will continue again with unit number 3, topic number 5, well irrigation, types of wells and construction of tube wells. Next, what is well irrigation? First, we need to know what is well irrigation. So here in this picture, I have shown you a well irrigation that is run by electricity. So well irrigation is a type of irrigation in which the fields of farmers are irrigated by using the well. The wells can be of two types. One is a one-man duct well and the another type of well is that which is run by electricity. So the one-man duct well is the one which you can easily see in the villages where people used to go and pull up water. And the second type, which is the well run by electricity, is shown here in this picture. Next, comparison with canal irrigation. So in well irrigation, crops may be irrigated using water drawn from well, which is very obvious, and which is then directed to the crops through channels, pipes, or by large vessels, directly to the plants. This can be time-consuming and tiring for the agricultural laborers. But in irrigation using canals from the water source is more convenient as it does away with having to draw or pump water from the well and other such storage tanks. When watering is completed, the canals may be closed to flow of water by sluices. Sluice gates. You can Google image and see about sluice gates. Next, types of wells. So there are basically 4 types of well. The first one is strainer tube well. In this type of well, an aquifer exists in the length of the well where a strainer pipe is placed. This is possible only in the alluvial tract. So in this picture, you can see the different layers below the ground level, how a strainer tube well is put there. Next, number 2 is cavity tube well. This tube well harnesses only one aquifer. It has small depth and has blind casing resting on a hard layer. Such wells are possible only in the alluvial region. So here it is a picture of cavity tube well. It has a cavity in the lower part of the well. Number 3, slotted tube well. Sometimes the nature of subsoil formation is not anticipated correctly. Obviously, borehole driven for constructing strainer will be a failure. If a hard formation is present, cavity well may be restored too. But if neither of the conditions are existing, the slotted tube well can be rightly constructed. There should be, of course, an aquifer present at the bottom. So in this picture, you can see a slotted type of tube well with the presence of aquifer shingle with slots in the bottom part. The last one is artesian well. Artesian conditions exist in certain regions like foothill region of Himalayas where the groundwater table is at a higher elevation. Groundwater comes out in the form of a fountain that flows out of the well by artesian pressure. Here you can see the picture of artesian well, how the groundwater comes out as a fountain. So this is our assignment for lecture number 18. The question is it necessary to have 2 wells for a pump? And what form of power is recommended for field irrigation? I repeat, the question is it necessary to have 2 wells for a pump? What form of power is recommended for field irrigation? So the last date of submission is mentioned here, you can see. Now we'll go through a video showing the well irrigation project in India. That's all for this class. Now you can give your attendance in the chat box while we see the video. Thank you.
In India, there is not a single instance where an irrigation project was completed within the stipulated time period. In spite of the implementation of 5-year plans, along with the programs like AIBP, which is also known as Accelerated Irrigation Benefit Program, none of the projects were executed before the planned date of completion. Since the water is not reaching the farmlands on time, it has resulted in delayed receipt of benefits. But Pattisima Lift Irrigation Scheme was completed within the scheduled time without extension of time, EOT, and any enhancement or revised budgets. This is the only project completed with fixed time and agreement value in the country. And this is the first of its kind of project in not only the subcontinent, but entire globe. And the pump house is also the largest, with 24 pumping units in the Asian region. Though the project constitutes critical civil works, wherein the foundation levels are far below mean sea level, MEIL has completed these works with local technological expertise. Pattisima Irrigation Project is India's first major river linking project connecting River Godavari and Krishna creating huge irrigation potential and economic value addition. There are many landmarks in Pattisima project. Some of them are as under. It is India's first major river linking project completed and commissioned in 1 year. Secured place for fastest construction in Limca Book of Records. Diaphragm wall methodology used for pump house substructure having heavy dynamic loading. Number of vertical type pumps, each 5,300 horsepower, 3.95 megawatts, ought to discharge 240 cumecs with 220 kilowatts substation and 12 rows of transmission, main of 3.20 meter dia, 18 mm thick, but used for total length of 47.10 kilometers. First irrigation structure with diaphragm wall method of construction in black cotton soils where hard rock is met with minus 11 meters. Project completed before contractual schedule. Project put into beneficial use in 6 months during construction phase itself. Asia's largest pump house. Excess utilization than designed during second year of operation. Pattisima scheme has been designed for pumping 80 TMC of flood waters. Second season operation has delivered 100 TMC of flood water utilization, and this, in turn, ensured 99% of area under cultivation. Flood waters, which was going unutilized, is being utilized, and this ensures timely water availability and reaping good yields. Risk of crop damages are mitigated as harvest period is ahead of aggressive monsoons and floods. Additional benefit of second crop owing to timely completion of first crop. No cost overrun due to before schedule completion. Return on capital employed is ensured as project is put into beneficial use even during construction phase itself. First pump commissioned in record time of 161 days and project put into utilization. Other benefits include seawater ingress in coastal areas of receiving basin is controlled. Groundwater recharge. Scheme ensures diversion of equivalent quantity of allocated water of Krishna Basin to water-starved Rayalaseema. Salient features of the project. The main components of the work are pump house, electromechanical works, substation, pressure main, delivery system, and erection of transmission line. Salient features of the project. Total discharge, 240 cumecs, 8,500 cusecs. Minimum water level, plus 14 meters. Delivery level, plus 42.50 meters. Types of pumps. Vertical turbine pumps. Number of pumps, 24. Discharge of each pump, 10 cumecs, 354 cusecs. Pressure main, 12 rows of 3.2 meters dia, 18 mm thick, length of pressure main, 3.925 kilometers each row. Capacity of each motor, 6,300 horsepower, 4.70 megawatts. Total power required, 113 megawatts. Designed lift, 80 TMC in 110 days. Major components in nutshell. Pump house. The pump house, which is spread across an area of 7,476 square meters, is the largest in Asia and is constructed using diaphragm walls as substructure, taking the benefits of saving time, elimination of flood risk, which is the first of its kind in construction industry. Electromechanical works. 24 number of vertical type pumps, each 5,300 horsepower, 3.95 megawatts, are to discharge 240 cubics, 8,500 cusecs, and 24 motors with 6,300 horsepower, 4.70 megawatts into Polavaram right main canal. Pumps are designed to place at a level so that it discharges when the water level in Godavari is at 14 meters or more during the flood days. Substation. A substation with 220 by 11 kilowatts is constructed at the site. The total power required for the scheme is 113 megawatts. Pressure main. 12 rows of 3.20 meters dia, 8 mm thick pressure main of length 3.925 kilometers is constructed to deliver water into delivery system. Delivery system. 74 into 90 meters delivery system is constructed to discharge 240 cubics of water into right main canal at CH 1.500 kilometers. Transmission lines. 220 kV transmission lines are constructed by taking connection from existing 220 kV Palantla switching station, which is about 30 kilometers far from Patisima lift scheme. Megha Engineering and Infrastructures Limited has set a benchmark to the entire construction industry. By completion of Patisima irrigation project, capabilities of Indian construction industry are proven and have been ahead of various standards or benchmarks at global level. Surpass customer GOIP satisfaction levels. After the completion of the project, the pumps have been operational for 1.2 lakh hours till now. This means that each pump has been operational for 5,000 hours without any hurdles. The pumps are well successful in diverting 4 TMC of water in 93 days in the first year, 2015, 55.6 TMC of water in 137 days in 2016, and 148 TMC of water till now in 2017.